theorems we're covering today are actually these four. There's four of them here. Okay, so starting with the first one, let me zoom in a little bit, it's hard to see. Okay, before we get into the words of it, let me show you with a picture. Here it shows two chords that are the same length. And if the chords are the same length, then the corresponding arcs are going to be the same measure or length. So in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, then the next one, it shows that this chord right here bisects this chord, and they're both the same length and it's perpendicular. When that happens, that means that SQ is a diameter. So if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. Or longest chord, I don't know if there's a better way to say that, but then this one's pretty similar. If a diameter of a circle is a perpendicular, if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So EG being the diameter, if it's perpendicular to this chord, that means that it bisects it, both sides are the same, and then both arcs are the same measure as well. And last but not least, congruency chord theorem. It means if you have two chords and they are the same distance from the center, then these two chords are the same length. So this would be the same length as this. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, we're going to flip over to 10.3 now. Let's see, 10.3. Okay, for the first set of problems, we're going to use that first theorem. So if you have a circle, and then you have two chords, and these chords are the same length, then the arcs are the same measure. And I'm going to zoom in here too. So for number 1 through 4, it says find the measure of the red arc or chord. Obviously, this is not in color, so you can just trace it with your pencil. This one, we're going to find the arc measure of AB. So either trace it with your pencil, if you have color, you can highlight it. This one's kind of hard to see, but this chord right here, this chord here, and this arc. Okay, so for number 1, it shows these two chords are equal, so that means these arcs are going to be equal. It shows the central angle 75, so that means the arc is 75 degrees, and that means this arc is 75 degrees. So the measure of arc AB is 75 degrees. And then for number 2, it's hard to see, this one isn't a great example, but there's a chord right here and it says it's 5, and there's a chord right here. Because these arcs are both 34, then this would be 5. So UV equals 5 units. Number 3, it shows this arc is 104 and so is this one. That means these chords are the same length, so this would be 11. So QR equals 11. Number 4 is a little bit trickier, but this segment right here, it's 1 dash and 2 dash, and that matches this entire chord here with 1 dash and 2 dash. So these chords are actually the same measure. So the arc here would be 170, and since this segment's the same length as this one, this would also be 170 degrees. Weird. Yeah. 11, because this is 11, and so this arc is, yeah. Okay, next set of problems. This one is based on the idea that if you have a circle, then you have a diameter of that circle and it's perpendicular to a chord, and it bisects that chord. This is equal to this. Okay, so for number 5, we're just finding the value of x now. X would just be 8. Then for 6, again, if the diameter is perpendicular to that chord, then these arcs are the same measure, so x is 40. Then for number 7, shows the same situation. To find x, we just need to put these two equal to each other. 5x plus 2 equals 7x minus 12. Did you mess up? I'll fix it later too. Okay. Some viewers still writing. Did you like 7x plus 5x to get 12x or something?
Oh, I added 12.
We'll figure it out later. Okay, on the next page, we aren't doing this her. We're gonna jump down to 13. This one takes a little bit of a jump, but the idea is, let's see. Okay, so we have a circle, and then the center of the circle, and then you have two chords, maybe one right here, and one right here. And these two chords are equidistant from the center, so this length is equal to this length, and then this distance perpendicular to this, and it bisects this chord. So these chords are the same length, but then they're also bisected. So this equals this, and this equals this, this equals this, and then of course the arcs are equal to each other too. Okay, so here it says find the radius of circle Q. So here it actually doesn't even show the radius. So notice how it has a segment here, but it like stops at that chord. So that's not even the radius. So we found that length, it's not the radius. But what we can do is like draw the radius. So from Q to H would be the radius. And then what we also have is a right triangle there, and so we can use that right triangle and find the hypotenuse to find the radius of this shape. So here it shows this entire chord is 16, so half of that would be 8. So this segment right here is 8. And then we need to find the length of this. Well, we are going to set these equal to solve for x first. So 4x plus 3 equals 7x minus 6. Okay, so x equals 3, so then to solve for this length, we need to plug that in. 7 times 3 minus 6 is 15. So this length right here is 15. And so to find the radius, the hypotenuse, we're going to use Pythagorean theorem. So I'm going to move down here. Say, okay, 8 squared plus 15 squared equals x squared. Square root of 289 is 17. I love how they knock so, like, let me just interrupt what you're doing. Hello, George. Okay, so x is 17, that is the radius. Radius is 17. Okay, that is all. You have the rest of class to get your homework done. As you have questions, please let me know.